Hi there. In this lesson, we're going to be looking at measures of central tendency and also some measures of dispersion. Measures of central tendency, the big three that we have here are mean, median, and mode. Okay, and most of us should be pretty familiar with these. Remember, the mean is the average of the data values. It's when we add up all the data values and then divide by how many we have. Okay, and we're all pretty used to doing things like that because that's how we calculate our grades and whatnot. So when we talk about the average, we're just talking about adding the data values together and then dividing by how many data values there are. The median is basically the one that's in the middle. All right. So in order to find the median, we always have to rearrange the data values so that it's written in order. So if I list all the data values in order and then I find the one that's in the middle, that's going to be my median. And if there's a tie between two values that are stuck in the middle, and I have two values that are dead center together, I basically take the mean or the average of just those two values to get my median. Okay? And then the mode is the one that just appears the most often. Okay, so as I look through, I see if there's any value that occurs more than once. And keep in mind, we can have more than one mode. If no value repeats, then there is no mode. But if more than one value repeats an equal number of times, then there can be multiple modes. Okay, so just the data value that appears the most often. And then the only other thing we look out for when we're talking about measures of central tendency, because that can be thrown off by this thing, is the outliers. Okay, outliers are basically data values that are way bigger or way smaller than everything else that's in the data set. And basically, we're looking for things that are going to affect the mean. If I have one data value that's much bigger than the rest, my mean is going to be thrown way off and might not represent the data very well. Okay, and that's why I have the three measures of central tendency, because they allow me to get a better understanding of where the data is centered around and kind of work my way around these outliers. Okay, for example, if I looked at the bowling scores of 8 bowlers, here they are. I want to find the mean, median, and mode. Well, the mean is fairly simple to do. I just add all these data values together. So I would just punch this into my calculator. I'm adding all of these guys up. So when I add all these together, it looks like it gives me 900. Let me write the mean down. When I add all these together, it gives me 976. And I have to divide that by how many bowlers I have, which is 8. And so when I do that, it looks like it gives me a 122. Okay, so that's my mean. My mean is the average. I add them all together and divide by how many I have. The next thing I want to look for is my median. And really, this doesn't look very nice in terms of the way it's written right now in terms of finding my median. So what I'm going to do is I'm going to rewrite the data so that it's in order. Okay, so it looks like I have a 104. I've got another one of those. Another 104. Looks like then I have a 109 would be next. So I'm just putting these data values in order. And once I have them written in order, I can kind of work my way to the center to see which value is in the middle. All right. And so now I have them written in order, and I just start counting from each end. I kind of take one off of each end and work my way to the center. And what happens is I get stuck right here in the center with these two values. Well, in order to find the median, I have to take the average because they're tied for the center value. So basically, I add those together. I do the 109 plus the 113, which gives me 222, and then divide that by 2, which gives me a 111. So my median this time is 111. All right? And then the mode is just the one that occurs most often. And since the data values are already written in order, that's a little bit easier to see now. I can see that I've got 3 of this data value. So that's clearly going to be my mode. It's the one that appears the most often. So the mode this time is a 104. And then just out of curiosity here, let's see if we have any outliers. Are there any values that look way bigger or way smaller than the rest? And I would say probably that this guy right here, this 189, is quite a bit higher than the rest. So I would consider that one an outlier compared to the rest of these data values. Okay? And so as I look at this thing, and I asked that question, which measure of central tendency is best for this data set? I would say probably the median this time. And the reason it's the median, more often than not, we go with the mean for the best measure of central tendency. But because we have an outlier, our mean gets dragged way up because of that 189. Okay? So because we have an outlier, the median ends up being the best because the median kind of cuts off those extreme values. So I'm going to say the median because of the outlier. Typically, the mean is one of our best unless we have outliers, because then the mean gets kind of tweaked a little bit because of those. The median eliminates the outliers, so I get a better sense of where all of the data is. Okay? If I was looking at something like this is probably the most useful thing to do in terms of our mean. But let's say with the grades that we have on 3 exams are 80, 93, and 91, and we want to know what grade do you need on the next exam to have an average of 90% on the 4 exams. Okay? So think about the way we construct the mean. When we do the mean, we add all the data values together, which is 80 plus 93 plus 91. But I'm going to have one more exam, plus I don't know what I'm going to get on that exam yet, so I'm going to call it X. Okay? I don't know what my score is going to be, so it's an unknown, and that's what a variable is for. And then I'm going to divide that by how many values I have, in other words, how many tests I have. And it says right here that we're talking about 4 exams. Even though I don't know what I'm going to get on that 4th exam, there's still 4 data values that I'm considering. Okay? So there's 4 tests being added together, even though I don't know what one of them is. So I add them all together, including the X, the one that I don't know. I divide it by 4. And I want to know if I can get an average of 90%. In other words, I want to know if this thing can equal 90, what I need to get a 90%. Okay, so I end up with this equation. And what I'm going to do here is I'm just going to combine like terms. So up here, I'm going to combine these like terms, the 80, the 93, and the 91. And again, that's just a job for my calculator, so I'm going to plug those in. Looks like it gives me a 264. So I get 264 plus x all over 4. And it still equals the 90. And what I'm going to do here is there's 2 ways I can approach this. I can either just multiply each side by 4 to kind of get rid of that fraction. Or the other option here is I can consider this as being 90 over 1. And now I can cross multiply. So here I would take the 90 times the 4, and when I do that, that's going to give me a 360. Here I'm going to take this value, the 264 plus x times the 1, and that's going to give me a 264 plus x. And now what I have is I've got this little equation. I'm going to rewrite it as x plus 264. Equals the 360. And now to finish solving this thing, I'm just going to subtract that 264 from each side. Really, once I have this thing set up, I'm simply just solving a linear equation. And it looks like that gives me a 96. So I'm going to need a 96% in order to get a 90% average. Okay? Which makes sense because that one score, that 80%, was much lower than the rest. In order to bring that up to a 90%, I'm going to need something that's pretty high. Okay?